All right, this lesson is lesson 10.5 on arithmetic series. An arithmetic series is a series that results from adding the terms of an arithmetic sequence. Okay, let's identify the formula for finding the sum, and it's S sub n equals n times parentheses a sub 1 plus a sub n, all divided by 2. And so let's identify these parts so we know what we're substituting in. A sub 1 is your first term. A sub n is your last term, and n is going to represent your number of terms. Okay, everything else, obviously 2 is a number, and so this is what you're going to use to find the sum of an arithmetic series. All right, we need to remember the explicit formula or rule for an arithmetic sequence. This will help us when we're trying to find the series. So we want to remember this to help us through this process. Okay, and that's the explicit rule for arithmetic sequences. All right, so let's find the indicated sum for each arithmetic series. We have S sub 9 for 11 plus 16 plus 21 plus 26 plus so forth. Okay, so we want to identify the parts of our formula that we need to know. So n is going to be 9. We need to know a sub 1, and we know that's 11. A sub 9, we do not know. In order to find that, we're going to now have to use our explicit rule. So we can say a sub 9 equals 11, right? We're substituting in here, plus we want to know 9 minus 1 times our difference, and we can see our difference here is 5 times 5. So a sub 9 will give me 51. Okay, so now I know that this is 51, and now I can substitute into my formula here for the series. So I'll have S sub 9 equals 9. Maybe I can squeeze this in. 9 for my n, parentheses, my first term, which is 11, plus my last term, which we found was 51, divided by 2. And then I'm going to do the math there, and I should get 279, okay, as my sum. All right. Let's look at example 2. I'm just going to move this over a little bit. All right, example 2. Now we have it in sigma notation. So I need to identify my n. It's going to be my upper limit as 7. A sub 1, I don't know yet, and I don't know a sub n, which is going to be 7. All right, so I need to substitute those in. So a sub 1 would be 3 times 1 minus 12, which gives me negative 9. And a sub n, which is 7, right, is going to be 3 times 7 minus 12, which will give me positive 9. All right, so I'm going to substitute in to my series formula. So S sub 7 equals n, which is 7, times negative 9 plus 9 divided by 2. Okay, well, negative 9 plus 9 is going to give me 0, and 0 divided by anything is 0. So my sum is actually going to be 0. Okay. Let's look at example 3. Again, I want to find my n, which is not going to be 11. Okay, we have to think, we're going to start at 2 here. We're not starting at 1, so it's actually going to be 10. And a sub 1, I have to substitute in here, so I'm going to substitute in 2, right? So a sub 1, my first term, is going to be 6 times 2 minus 8, okay, because that's my first term is 2, not 1, right? So I'm going to end up with 4. And a sub n, which is going to be 10, okay, a sub 10 is going to be 6 times the number 11 minus 8 will give me 58. Okay, so be careful. If it doesn't start at 1, you have to think about how many terms you're doing, and we're doing 10 terms, even though we're substituting in 11 for the upper limit. So now we're going to substitute into our formula, S sub 10, because we're trying to find the sum of 10 terms, equals 10 is my number, right? My number of terms. 4 is my first term. 58 is my last term, divided by 2. And I should get 310 as my sum. Okay. All right, let's look at example 4. It's written a little bit differently. We have S sub 7 where A sub 1 equals 4 and A sub n equals 46. So we have our n as 7, our A sub 1 is 4, and our A sub n, which is A sub 7, equals 46. Okay, that information has been given to us, which is fantastic. So now we just have to substitute it into the formula for the sum, and we have 7 times 4 plus 46 divided by 2, which would give us 175 as our sum. All right, and that is less than 10.5 on arithmetic series.